Okay, calculus. Before we move into lesson 7.2, I want to just recap with you some things you need to keep in mind from lesson 7.1. So as we go through these examples, I'm going to highlight some of those details that you need to start including in your homework papers. Let's go ahead and get going on this first one. We're going to just set up today the integral for finding the volume bounded by these two functions. So the first function says I have an upside down parabola that starts up here at 0, 2. So let me go ahead and get that graphed. And then y equals x squared. You guys all know what that looks like. All right. So here's our points of intersection. Now, if I graph this perfectly, which I am unable to do, and you guys know how great of an artist I am, I would have two areas that are of equal value. So I can either integrate from -1 to 1, or 0 to 1, or -1 to 0, and double those areas. I'm just going to go ahead and do my area from -1 to 1. And what I want you guys to focus on, a couple of things. I want you to highlight that area that you're finding. So shade in the area that's bounded that you're finding. And I also want you to include a rectangle that shows the process of integration. So in this case, I'm going to do a vertical rectangle that shows the top function and the bottom function right there. That rectangle is going to be crucial when we start doing volume. So I want you guys to start drawing it in when you do your graphs. Okay, so to set up my integration, I'm going to do my top function minus my bottom function, and then I would go from there. So today's focus again is getting you to graph it properly, shade the area that you're finding, and thirdly, just draw in that rectangle before you set up your integration. I want to see that rectangle on everybody's paper. Number 2, when you're facing equations that are solved for x, I do not want you to rotate your axes and turn everything another direction. I know, Jacob, you are doing that when you did these problems. I don't want you to do that. We won't be doing that when we find volume, so don't do that here when we're doing area. What I want you to do is go ahead and graph them the way they are. However, if I'm graphing this one, I will solve it for y just because that's more familiar to me for graphing. So if I solve for y, I'm going to have -x plus 2. And let me go ahead and get that graphed. And then x equals y squared is your parabola that opens over to the right. Okay, again, this is the area that you're finding. Go ahead and get it shaded. Now, I want you to try to set up your integration so that you're finding as few number of integrals as possible. So, for example, if I were finding the area of the shaded and I did vertical rectangles, I would have to split my area here down the middle and do one rectangle for this part and one rectangle for this part, since they have different top functions. What I want you to do on this assignment is try to do this problem with the fewest number of integrations as possible. In other words, if I turn my rectangle horizontally, I will have one rectangle instead of 2. That means one integration. Now to do that, I'm going to have to know my bounds. I'm going to have to know this point and this point, and as you know, I'm like a horrible grapher, so technically these points should have been easier to read, at least that one. So I'm going to have to do a little bit of work to figure out what that is. So let's see here. A little bit of factoring here with some substitution. And let's see, when y equals -2, our x is 4. Okay, so here's our y bounds. This is what I needed anyway, so that I could figure out our integration. So I'm going to go from -2 to 1, and then I'm going to do the left here and the right here, and it's always right minus left when we set up our equation. So right minus left, 2 minus y squared. If you were to flip the order of subtraction, you would come up with a negative area. So again, it's going to be right minus left. Okay, moving on. This next one. Okay, negative x to the third plus 3. Y equals x, bounded by x equals -1, x equals 1. So I'm going to go ahead and graph my vertical boundaries. Okay, y equals x comes through like so. Negative x to the third plus 3. So I'm going to go up 3. When x is -1, I'm at 4. When x is 1, I am at 2. Let's see here. It's going to be coming down something like that, I would imagine. All right, what area am I finding? Well, it's going to be this area right here. All right. Set up your rectangle. So it's going to go right there. I'm going to integrate from -1 to 1, the top curve. Oops, how about plus 3? And then minus the bottom curve. And then dx. Okay, our last one. We're going to go from 1 to 5. And then we're going to plug in, let's see, when x is 1, our y is 1. When x is 2, we're at 1/4 and so on. So how about I scale this 0.25, 0.5, 0.75, and 1. So we're going to be 1, 1, 2, 1/4. If I do 3, I'm going to be at 1/9. That's 0.1. So something down here and so on. So this curve's going to come in and just kind of ride right along there. And so this area here is what you're finding. All right, I want to see that rectangle. Okay, so we're going to be going from 1 to 5 of 1 over x squared, and go ahead and put the bottom function down as 0. I know right now that 0 is really irrelevant to you, but as we move into volume, you're going to have to show subtracting that lower bound, and maybe that lower bound is actually a line like y equals -3 instead of y equals 0. You're going to have to account for it. So go ahead and start putting in that 0. And then you would integrate from there. Just a side note, on your integration for this one, 1 over x squared does not integrate to be the ln of x squared. Remember, you have to do that, and then you add 1 and divide by your powers. So be careful with that. Some of you are taking anything with 1 over and you're saying that's natural log when you integrate it, and that's not correct. All right. So when you do your homework worksheet tonight, what you're going to be doing for me is setting up those integrations for me with the area shaded and the rectangle drawn in for each. And then I need you to actually carry out the integration on at least 4 of them. So on 4 of them, go ahead and integrate your choice and go from there and get the final area answer. So again, homework requirements, graph if it's not done for you, shade if it's not already shaded, put the rectangle in that you're using for your integration, and then on any four of your choice, I want you to actually integrate and find the answer. That's it. Thanks for tuning in. Miss you guys.